Good morning, and welcome to the middle school science class today. My name is Mr. Paul, and I will be your teacher. I hope you had the opportunity to watch all the amazing lessons that were presented before me. But we're going to shift gears just a little bit, and we're going to move into some science and explore some hands-on experiments that you can do at home. So the very first thing that we're going to do today is we're going to use 3 cups, some water, 3 eggs, and some table salt. So the very first thing that we're going to do is we're going to pour water in 3 cups, and you want to make sure they're equal. Now, I'm using 3/4 cup of water for each cup. Now, I've already marked my lines to make it a little bit easier today so that I don't have to focus on making sure that it's the exact same amount. Okay. Now, the next thing that we're going to do is we're going to put some table salt into each cup. Now, I've already got mine measured out to make it easier today. There's 3 tablespoons of salt per cup. So I'm going to put it in the 2nd and 3rd cup. Now, I'm just using table salt. You can use any type of salt you want. Just make sure you're not using all your mama's Himalayan salt. She might get upset. Now, we're going to mix the salt in cups 2 and 3, and it's going to form a mixture. So one of the first things I always do in an experiment is we want to look and see if we can notice anything that's changing before we start. Now, as you notice, in cups 1, it's very clear. Nice, clean drinking water. Something I'd want to drink. Now, cups 2 and 3, a little bit murky. Not something I'd probably want to drink. Just a little observation to start with. Now, we're going to use 3 eggs. It doesn't matter the style, just 3 eggs that are the exact same. I have jumbo to start with today. And we're going to place the eggs into each cup. Well, wait, what do you think is going to happen? Do you think the egg is going to sink to the bottom? Do you think it's going to float at the top of the surface water? Not sure. Do you think it's going to stay in the middle? Or do you think a chicken is going to pop out of it? We'll have to find out. So, let's place an egg into each one. We notice in the very first cup with just water, the egg sinks all the way to the bottom. Okay. So now we're going to put an egg into the 2nd cup with salt water. It didn't do the exact same thing as the first cup. It floated back to the top. Wonder why that is. So we notice that in cup 2 with the salt water, the egg floats instead of sinking. Let's go ahead and put the egg into the 3rd cup. Makes sense. It does the exact same as the 2nd cup. Has the same amount of water, same amount of salt. So what's going on here? What makes it different? Yes, you in the back. Perfect. Salt. Yes, obviously. But what is salt doing to the water to make it different from the first one? That's the question. Let's do one more thing before we move on to see if we can figure out why. We're going to manipulate the last cup just a little bit. We're going to pour some extra water into it. Let's see what happens to the egg when we pour water in. Okay, it's changed. But now the only thing we've changed is by adding extra water. So now the egg is floating in the middle. It hasn't sank all the way to the bottom, and it's not at the surface level. Again, why is this? Well, let's find out. We're going to move it into our PowerPoint. There's my clicker. And we're going to talk about density. Density what now? Sorry. Pretty lame science joke, I understand. Now, you probably couldn't hear the sound effects, but it's probably the worst sound that any science teacher wants to hear in a room. Sound of glass breaking. So remember, don't break the beakers or your mom's glass while you're doing this. So the first thing that I always talk about with my kids, that I always start the beginning of the year off with, is solids, liquids, and gases. Yes, we all know what solids, liquids, and gases are, but I want to focus on the particles that are in each one. So the particles in the box right here with the solid, you're going to notice that they're more compact. They don't move as much. They actually don't even pass each other. They vibrate. The one you don't see is a liquid. So the liquid has a little bit difference in variation. The liquid's particles are allowed to slip over each other and move around in the form and shape of whatever the liquid's in. And the gas, on the other hand, is allowed to freely move around in whatever container that it's holding it. So the particles are not compact at all, whereas the solids are very compact. Now, many factors change this. The density of the object, different materials have different weights, and different amounts of matter. In saying that, temperature also affects this. So if you're doing an experiment and your experiment was one with warmer water compared to cold water, the particles are going to move differently. The higher the temperature, the faster the particles are going to move. The lower the temperature, the slower they'll move. Is this related to density? Yes, sort of. And the reason is density is how much matter there is given in an object. And this can be different depending on the matter. For example, if you have 2 cups, one filled with water and one filled with clay with the exact same amounts, you would obviously think the clay one's going to be heavier, right? Yes, because clay is a solid and has more mass and a greater density because the particles are compact within it. So, the clay cup is going to be much heavier than the water. Now, again, just like with everything, this is the usual rule. There are exceptions to it. So generally speaking, we have solids that are the most dense, liquids are in between with medium density, and gases have the least amount of density. Now, like I said, there are exceptions to this rule. Think about wood. I know especially out here in the country, a lot of kids like to go to lakes and ponds and throw stones in the water and they sink. But sometimes they throw sticks in the water, and when that stick, what happens? It floats. Why is that? Well, the log plays a different role in this. Why? Because the particles in wood are a little bit different than normal solids because they have air pockets inside the wood that makes them less dense. As you can read right here, the clusters of particles in the pockets of air cause it to change the overall density. So wood is actually a composite of solid and gas. So the particles are a little bit different, and they do a little bit different things. So density and buoyancy. Pretty simple. If it's too heavy, whatever substance it's in, it's going to sink. If it's lighter than density, it's going to float. So if an object's substance is less dense, it floats. If the substance that it's in is heavier, it sinks. So, we're going to try this. Get 2 buckets of water, 1 can of Diet Coke, and 1 can of regular Coke. I'm going to use 1 bucket because it's going to be easier for you guys to see, and we're going to use 3 sodas. We're going to use Diet Coke, we're going to use Sprite, and we're going to use regular Coke. But before we do this, what do you think is going to happen? Just like the egg. Do you think they're all going to sink? Do you think they're going to float? Or sit in the middle? Let's find out. Let's put the Diet Coke in first because no one really likes Diet Coke anyways. Okay, so it's hard to tell, but the Diet Coke is floating. It's not very deep, but you can see that it's floating at the surface of the water. Now Sprite, which is one of my kids' favorite drinks, no caffeine. It floats a little bit, and then it starts to sink at the bottom. That's weird. They have the same amount of volume. They're both 12-ounce drinks. They're both in aluminum cans. I wonder what the difference is. Let's try the Coke now. Now, by the way, I had a few problems with Coke earlier in the day. It wanted to float for some odd reason, but I think my temperature of my water was a little warm. But in this situation, the Coke sinks to the bottom also. Again, all 3 cans are the exact same volume. All of them have 12 ounces of fluid. All of them are in aluminum cans. So what is the difference? The amount of sugar in each can is the difference. The Coke can have a much larger content of sugar, making it more dense than the Coke. So obviously, as my PowerPoint says, we're going to spoil it for you. The Diet Coke will float to the top because it has sugar, whereas the Sprite and Coke is going to sink to the bottom because the density level in the volume makes it more dense. The amount of sugar changes everything. So, can a substance become more or less dense? This goes back to experiment number 1 with the eggs. What changes everything right here? Well, the first one we had just water in the first cup, and then in the second cup and third cup we had the same amount of salt. And they had the same amount of density until we decided to put more water into the third cup. And when we put more water into the third cup, it changed the density level. That is the factor here. So yes, we can change the density. Now, if I added more salt back into the third cup, the density level would increase more, and the egg would start to float back to the surface. So, simple answer, whatever's in it matters. Matter matters. So, this is a good representation of extra particles that we're putting in. More amounts of salt, more particles, more density. More density added will increase the volume of the water. So, here's a little last little science thing. Density got you down? Don't be sad or intimidated. We love density. After all, density is the reason you are floating up and hitting your head on the ceiling. Whew, for density. Okay, so we're going to have one more experiment before we end the day, and we're going to move to the back of the classroom, which is perfect because this will be just like your kitchen sink in your mom's kitchen, working with what you have in there. So this very last experiment, we're going to use some household utensils that you have. Different combinations of mixtures that you can use at home too. So what I'm going to use is I'm going to use honey, corn syrup, butter syrup, or maple syrup. It's the same thing. Whole milk, any kind of dish soap, which is Ajax for here. Then we have oil, alcohol, and lamp oil. So we have 8 different things that we're going to put into this jar. And we're going to check the density levels of each. Now, it's very important that when you do a project like this that you understand the density levels. There's 2 ways of doing this. First, like most people, you can Google and see what the density rate is. Or you can check the back of the labels. Now, if I check the back of the label on the honey, it has 60 carbs and a large amount of sugar. The corn syrup, on the other hand, has 31 grams, which is less dense than the honey. So I'm going to start out with the honey. Now, unfortunately, the ants have decided they like the honey too, and they're trying to get into part of this experiment. So what we're going to do is we're going to level off each one. I have already filled each of my first 3 because they are really hard to get out of the container and it takes a large amount of time. But I have a half cup of syrup, a half cup of corn syrup, maple syrup, and then I'm going to do milk next. So we're going to start with honey. When you're putting it into your container, you want to make sure that you're not touching the walls, because if you do, it's going to cause it to mix later on, because again, honey is much more dense than some of my other materials up here. And again, this takes some time. Obviously. Okay, so we're going to leave just a little bit in there because it's going to take a while. So the next thing is we're going to do corn syrup. Again, take your time, make sure you go right in the middle and dump it in nice and slow. Now at first you're going to notice that the corn syrup goes directly in the middle of the honey and pushes down. But after a few seconds, you're going to notice that the corn syrup starts to rise back to the top because the density rate of honey is more than the corn syrup. So again, we've already got 2 nice little levels here. We have the dark honey on the bottom, and then we have the corn syrup right above it. Now, this is the first layer. Now we're going to go to our next one. We're going to put in our butter-flavored syrup, which hopefully you used on your pancakes this morning. Now again, notice the same trend. As I pour it in, the syrup pushes down in the other corn syrup and into the honey, but eventually rises back to the top. Now, same thing. Now we have 3 distinct layers. Really easy to tell which one the honey is, which one the corn syrup, and which one the maple syrup is. All right. Now we have to change it up a little bit. So I'm going to use the milk next. Now, I'm not going to lie, this took a few times. Make sure that if you're going to experiment with it, you keep your milk cold or do room temperature, because if you change the variations of your experiment, the particles will change also. So, what you're going to need for this one is one of these bad boys. We're going to suck up the milk slowly. And then it's important that we change the method on this one. We don't want to pour it directly in the middle like we did the other one. We're going to have to pour it on the side and let it slowly make its way in the container. Now, I tried this a few times, and if you don't do it this method and you dump it right in the middle, the mixtures will start to mix, especially when we get to the dish soap. Now again, make sure you're doing this in the kitchen with some parental help so you don't make a mess and your mom comes home to this. Okay, so after that, what you need to do is make sure that you wash out your utensil, because if not, you're going to have some milk bubbles in a second, and that's not going to be very helpful for this. So the next pour in is Ajax dish soap. Again, this one's slow too and takes some time. And if you don't take your time on this one, this is where your tower will start messing up. Because like I said, they will slowly start mixing as I drop some right in the middle. Man, this is the quietest my class has ever been. Only if this was like it was when you're doing experiments in the classroom. No, I'm just kidding. I really like the noise. If you've ever been in one of my classrooms, I probably make my other teachers a little upset because we're pretty noisy sometimes. Part of learning is interacting and talking with your fellow classmates. So, I told you this will take a little minute. Got it nice and slow. If you rush this part, your tower will start to become a milky Ajax mess. And we don't want that. Yes, question in the back. Yes, I am out of dress code. Sorry, I am wearing a hat today. Why is that? Well, let's see. With everything that's going on, our barber's been closed for the last couple of weeks, and my hair is a mess. I feel like I'm like one of my other students in my classroom, and I have to have a ponytail holder to hold my hair up. So we're gonna avoid that one. Yes, that is true. Lou, you know who I'm talking about. We'll use your nickname so no one knows. Again, this is a lengthy process, but has some amazing sounds to go with it if you want to take your time and do it. Now, my son found it more funny to do this part than the rest because all the fart sounds that it made with it. But you know, we'll be all right. That's right. Okay, so one last little syringe of this, and then we'll move on to the oil process. Like I said, it takes just a little bit of time. All right, again, so after the first couple times I did this, I didn't wash this out very well. In saying that, if you do not take your time to wash it out between each part, the soap will mess up the rest of the experiment. Now, the great thing is everyone should have a lot of soap with everything that's going on now, washing your hands constantly. So, try not to make too big of a mess here. The next thing is we're going to put some oil in. Again, I already have these pre-measured out with lines to make it easier, but I am using half a cup for each substance. Just like with the eggs that we did earlier, we want to make sure we're using the exact same amount to make this look good and work out properly. Now we're going to have to do the same thing that we did with the Ajax in the milk. You have to take this step slowly because the density rate between each one of these is slight. They vary by just a little amount. So if you rush these, what's going to happen is they're going to slowly start to mix. And I promise you that if you're doing this with a parent, they're not going to want to do this too many times if you're wasting a whole bunch of household materials. Again, see, I didn't clean it out very well, and now I'm starting to get some soap at the top level. All right. That one went a lot faster than the first one. This is going to be our last time that we have to rinse this out, because the great thing about alcohol is it will help get rid of everything else that's in this. So, our next one is some rubbing alcohol. Any, as long as it's rubbing alcohol. This one's 91 proof. Anything I believe above 70%. Anything below that, that becomes a little bit subjective to the oil below it. And if it gets too high of 100%, it's going to start messing with the lamp oil. So anywhere from 71 to 95%, which most of the time when you buy rubbing alcohol in your store, it's going to be around 91%. So before we go into that, we're going to put some food coloring into it. Why? 4 minutes? I got to speed it up. That's what I'm being told. So we're just going to skip the food coloring then. Now I'm going to try to speed through these last two so that we can get to a few more things to go with this. Because even though we're doing a density tower, we're going to do an experiment with it too. We're going to check the density rate of other objects by dropping them in as soon as we are done with this tower. Now typically, I would add some food coloring into the last couple levels to show the differences, especially if they're both clear liquids. It's going to start getting hard to tell which is which. But there will be a slight difference in coloration between the lamp oil and the alcohol, even though they're pretty clear. All right, so that step's done. Now we have an 8-level density tower, starting with the honey at the very bottom being the most dense liquid that we have in here. And at the very top, we have lamp oil. And if you notice, there's pretty variations between each one. Now again, if you notice, the darker liquids are at the bottom. Obviously, the Ajax is in the middle with a little bit of food coloring in it that they've already pre-mixed. But everything else, the dark liquids are at the bottom. They're more dense. The honey is at the bottom, the syrup, and the corn syrup. So before we end, we're going to drop a few things in here, just different objects to see where they land. Now, I'm going to start with the screw. This one's probably the most obvious. You're probably going to say it's going to land at the bottom, right? That's what I would do because it's metal. So let's drop it in. Let's see where it lands. Again, it dropped all the way to the syrup, right? All the way down to the honey level. So the next one is we're going to drop a popcorn kernel. Where do you think it's going to land? Let's wait and find out. Now, if you notice, it should have stopped anywhere between the milk and the Ajax level. Shouldn't have gone much further than that. The syrup is too thick for it to go down. Let's do a cherry tomato. I know it's growing season. Let's get those gardens going. Again, that one should stay above the syrup level also. I know it's kind of hard to see. It's in the Ajax. Perfect. Last one, we have macaroni and cheese noodle. I know you guys love them. It's one of my daughter's favorite lunch materials. So here we go. Where'd it go? Can you see it? Okay, so that one should have actually landed right in the material right above the Ajax. The last one's ping pong balls. I know you guys have them. I'm going to skate these all the way at a time. Where do you think it's going to go? It's going to float, right? Right at the top. We're going to put some chocolate in last. You know, got to throw some chocolate in. No, I'm just kidding. I'm going to eat this one. In saying that, I hope you guys have enjoyed the experiments today. Thursday, RSU TV will be on again with some Sequoyah teachers. And next Tuesday, I will be on again. I hope to see you there. Thank you.